All right. You're right. So they can see. Okay. Minimize. Close that. And back to this. Might help if I plug in too, but oh, he got up there finally. Cute. Welcome, everybody. This is episode 64 of the Swift and SwiftUI Learnalong. I am your host, me. And I think I'll do staggered intros now because it takes a while. But I just want to give folks the lay of the land in case, what's going on here? There we go. Don't rush me, brother. We got all day. Okay, so let me give you the quick intro to what's cracking here. If I can get there we go. Okay. So this is a learn along, not a course itself, meaning no direct interaction, although by virtue of me going through the learning material, I narrate it to you. Obviously, I show it on screen. We do the code samples. And so while I learn, you learn. So true to its namesake, learn along. At least that's the idea. But just FYI, so you're not watching an expert. You're watching somebody learning in real time. And hopefully that's a value add to you. But if not, well, brother, looks like this ain't the stream for you now, is it? No, not really. But well, actually, that's not a joke. That's true. But yeah, I just want to lay that out because it's not one of those where I'm, just expertly kind of dicking around showing you how to do. That's not what this is. So while we learn this, the intent and what we will eventually end up doing is actually building a product that I intend to sell, as my company's first product, which will be an app called MRP Panda. We won't dig too much into what it does. We've talked about it a lot, so we won't. I won't torture you for now, because eventually we'll just start building it live on stream. So if you want to see what it's like to actually build an app, we can discover that together, because that's what eventually I'm going to get to. Now, as far as what we've already done, if you go to this YouTube channel, this at Nico X narration, okay? This is where you can go to see all the past streams, because everything has been done in a linear fashion. Everything's been done on stream in terms of what we've learned here. So we've already, the first 46 episodes, if you were to go to this YouTube channel, the first 46 episodes of this learn along covers Swift proper, meaning just the language itself. So we read through this 818 page behemoth of a book written by the Big Nerd Ranch Guide, or the Big Nerd Ranch Company. Awesome books. If you're looking for anything programming related or technical in nature, I would check their stuff out. I just like their teaching style. I think it's great for beginners. They're very, very nuanced, give you tons of examples. They don't make the assumption that you have a computer science background effectively. So I like their stuff, so shout out to them. But anyway, that's what we've already worked through. Now, currently we're in the throes of learning SwiftUI and Swift Data, which are Apple frameworks. And we've not dug too far into it, but we've gotten a little bit done, maybe 4 or 5 episodes in. So yeah, this is where we currently stand. By the end of the book that we're reading through now, shout out Big Mountain Studio, by the way, because they let you directly on their site. They support content creation around their material. All they ask is that they get a shout out, so giving them a shout out. And I'll go show you the site here in a second. But yeah, that is appreciated. That's really cool. Because I was honestly worried whether or not my content would get taken down for that reason. But thankfully found these guys, so since they're good with it, I'm just gonna stick with their material. But it's honestly, beyond that, it's the only site that I found that actually has up-to-date SwiftUI and Swift data, which, like I said, are these two. The only ones that had courses that are centric to these two and not using its predecessors, which is the old stuff, the Objective-C stuff, UIKit and core data. So that's another thing. If you're looking for a stream that's going to cover those, all jokes aside, this is not the stream for you, because I have no need to learn those, and therefore will not be learning those. So if you're looking for something that's covering that, that it's not going to be here. Now, by the end of it, like I said, we will have written 3 full-featured apps. That's based off what the book is telling us. But so far, we've just been more or less been classroom style, going through slides and stuff. But it's still very helpful. So we'll get to that in a sec. But after we get through SwiftUI and Swift Data, this book that we're working on now, we will spend a few days setting up the web server for the application. I'm going to use GraphQL just because I want to. And SQLite. So we'll do some schema design. You'll get to see what that process looks like if you haven't ever done that. So that should be cool. I've done plenty of SQL schemas and all that jazz. Wrote SQL for 10 years. I would say I'm about expert level. I don't want to brag, brother, but no, but really, I know it pretty well. Now, as far as programming though, I wrote some Golang applications, server-side apps for ETL type, data pipeline stuff. But I'm no expert. So this is more or less, you're watching a beginner when it comes to iOS apps for sure. So it'll be interesting. Now, once we do the design there, we won't spend too much time on it because it's going to be iterative. It's going to change. And so then we'll just start building the app. I've accumulated tons of really, really cool, powerful SwiftUI tools that I intend to use, but I still want to learn the basics, so that's why we're going to go through the books anyway. But yeah, really cool tools that should help speed up the process and help avoid mistakes, stuff like that. And then anytime that we have where I'm feeling, like I hit a wall with design or whatever, we'll bounce over and look at some C programming, but we'll keep it centric to Swift. So I think it's important to just know C generally speaking, because it's not a very complicated language. I've done some coursework on it, like 2-3 years ago. So I want to get refreshed on that, but then also, more importantly, we'll look at messing around with using C libraries in our Swift apps. That way, we know how to interact with other libraries from other languages. I think that'll be a handy and necessary skill down the line. And then we can save ourselves, if we get serviceable at that method, we can avoid a lot of heartache. We don't have to rewrite a lot of stuff that's just already there. Okay, so that's the general outline of what to expect here. So if that sounds good to you, please do drop a follow. And also, if it doesn't sound good, well, get the hell out. All right, so where were we yesterday? I'm just kidding, you don't have to leave, but you might be disappointed with the content. All right, now we were at animation. Yes, animation. Okay. Oh, wait. One more thing. I didn't go to the website, so I will do that right this moment. Big Mountain Studio. Yeah, and one point on this. So this is obviously the book that we're going through now, Swift Data Mastery. And after the fact, I'm not sure if it'll be immediately after or what, but for this stream, I can tell you I will at least be back for... there was an animation one. No, where is it? SwiftUI books. Why is it so ginormous? There we go. There it is, SwiftUI animation. So this is something I'd really like to get a mastery of as well, because it's fun, It's fun to know. So I want to do that. So we're at least gonna, meaning on this stream, we'll at least look at. Or not look at. we will at least go through one more Big Mountain Studio course, but I would encourage you to come check them out, generally speaking, just because, like I said, it's the only, I've checked 14, 15 different sources for Swift online. They're the only ones, thankfully they're really good, but they're also the only ones I could find that were SwiftUI and Swift data centric, meaning, up to date. A lot of the others kind of focused on both or just left them out altogether, and that's no bueno. I don't want to learn the old shit. So now we can get to it. Okay, so far we have gone through, let's see, setting up a model. So just generally speaking, just so you can kind of get an idea if you're coming into this late of what the overall flow is. They covered that way up front here. So we're in effect just doing more, what am I trying to say here? We're doing a lot of examples that all fall under these four different concepts here. So the data model itself, which is effectively our types that we define, our classes rather, since SwiftUI requires that we use classes. The container is more or less the frameworks that we're using, the tool kit that Apple provides. So SwiftUI, Swift Data, among others. The context, which is effectively anything that is currently in memory. So while we're actually running our app, when we refer to the context, we're talking about any data that's been, any metadata and user data that's been loaded into memory and is currently sitting there ready to be manipulated or viewed or whatever. So that's context. And then the view itself is, of course, what the end user interacts with. So everything we're doing is pertaining to one of these four concepts and how they interact. Okay, so that being said, we've looked at the model, we've done some examples. We've already set all of them up. So if you wanted quick examples, you can see these in past episodes already, but now we're just digging into more, robust examples using more of the functionality of SwiftUI. And thus far, we've played around with some mock data. We've learned how to use data in development. We've learned how to persist data, meaning if we wanted to save, work with your app and test it out and actually save data to disk such that we can use it later on, even after we've, shut down the machine, whatever. We've already set up a dev environment where we're actually installing the unpublished app, the unfinished app on your own device. So if you have your own iPhone, you can do that and actually get a real legitimate example of what it would be like to use your app. So that was pretty sick. And then after that, we've been looking at some of these macros like query, model. It's starting to make more sense, but I'm not going to sit here and tell you I got a deep understanding of it yet, to the degree that I felt like I did with, like when we were going through Swift proper, looking at functions, looking at protocols. Those made a lot of sense to me. I'm not feeling like that confident with the SwiftUI stuff yet, but it's a lot of ideas coming at us, but we still have plenty of this book to go, so it'll come with time. But now we are at animation, and so it begins, brother and sister. All right, the query macro. One thing real quick that we learned yesterday is that, I didn't. Oh, there it is, yeah. Yeah, so there's @query, right, which is the macro. But then there's also just a query, which is a type. A SwiftUI type. And this is a SwiftUI macro. Now, generally speaking, what they told us is oftentimes we're not going to interact, and likely Apple's going to change the way that we even use the type query. So I wouldn't dig too much into that, but if you come across that, I found it particularly confusing. and kind of wish they would just not have shared the name, but whatever, it doesn't matter. But @query is a SwiftUI macro. Actually, a better explanation or alternate would be it's a property wrapper. So, which basically allows you as the developer to wrap a property, and then SwiftUI will provide a way to fetch that data, whether it's from the context or whether it's from the data store, the persistent data store. But yeah, just FYI. Okay. So that being said, now we'll get started. The @query macro also has an animation parameter. You can use it to customize the animation as query results change. Filtered, sorted, added, and removed. So those qualify as, or each of those would qualify as a change. Okay. By default, there is no animation. Note, sometimes the view you use overrides the animation you set. This is especially true with the list view. Yeah, I heard about this. So I guess that's more so to, I guess for whatever reason, because SwiftUI is not open source like Swift, the language, is. And so I assume, well, actually, I don't have to make the assumption. Apple controls SwiftUI, so my assumption is they do this so that they don't have to worry about the developer creating a inconsistent kind of experience on their devices. So it's like it's a restriction, but I suppose depending on how you look at it, you could think of it as it's a nice restriction. It's a good thing that it's there. On the whole, I think probably a good thing, unless you really just needed to control like what your menus look like whenever you're adding shit on there. But I don't think most people will care. Let's see. Yeah, so the way these slides are set up, they'll often give us an example, but isn't this great? I mean, look at this. You get a video example, so we can actually see the behavior. I'll play it here in a sec that we're talking about. And then all of these little visual pointing to the areas in the code. Fantastic. And then you also get the project. So we have all this code as well. I'll occasionally pop over and look at it, but thus far, I mean, these slides have been great to just learn directly from the slides. Now, normally I'm a fan of typing the code out because we did that with the Big Nerd Ranch guide, you know, just muscle memory. Like, I'm definitely a believer in all that. It definitely matters. But given we did so much of that throughout the first, 50 episodes or whatever it was, I'm cool with just the slides because we're going to get right into building after this. So just FYI. All right, so let's see what they're talking about first. Animation, what you got? Okay, so we're removing items, we're deleting records from the view, and it's using this little fade out animation there. Even though you see an animation, it is not what was specified, which would be the ease out here, this modifier. In this example, a 2-second animation is set. When a park is removed, you should see the removal happen over 2 seconds. Okay, and it's obviously much faster than 2 seconds. So this is where they're saying the list view just overrides whatever you put here, although they still let you put something there, which is interesting. That's oh, whoops. That open right now. Not right now. Okay, so why isn't the animation working? The list view is now animated, but it will not use your animation specifications. It will override your animation and use its own built-in animations. Okay, we just read about why, so that's cool. Turn that down a little, brother. Background music going ham. Okay, so now list animations on or off. When using the list, you can see that it doesn't matter which animation you use, is simply on or off. The list view uses its built-in animations. Okay, no animation, which would look like so. Just the property wrapper, private var, parks of type park model array. And it looks like pretty herky-jerky. Let's play it again. See that there? Very unsmooth, very robotic, claymation type shit. Okay, now second animation. Same property wrapper, but with a oh, so you can pass it. That's cool. But even still, this gets ignored because it's a list view, so that just supersedes it. And now it's doing that ease out, but not over 2 seconds. Let's see, these two are exactly the same, so we should see the exact same thing, and we do. They're not lying to us. And this is with the code dictating a 10-second fade out, but in both cases, 10 or 2, Apple's like, nah, bro, fuck you. And it just does what it wants. And so that is what we've learned. And that makes sense. That would be kind of silly anyway. But yeah, I mean, I can totally see why they did that. A 2 second fade out would be a bit over the top. And I can see how that might bleed out into the user experience at large. So do as you wish. Non-list animations. Okay, so now what is this here? So now we have a new view that no longer contains a list view. And we are a 2 second animation is being used again. Okay, so we're still dictating ease out duration 2 seconds. With a scroll view plus for each instead of the list, you can see the difference now. What the? How did it delete all 3 though? Or how did it know to? Huh, okay, well you can definitely see the difference. Toolbar, button, system image, model, delete. Oh, did it click it 3 times? Maybe it did. It did, okay. Okay. I guess that can't be the reason then. I mean, I can't be correct about why Apple would have done that. Maybe they just did that for list specifically and for others, but still give you a way to work around that in case you did want some kind of, I don't know, maybe, who knows. Anyway, we can see the difference, and the point is that we can still handle list either using list view, where our animations will be ignored and list will use its own, or we could do scroll view with the combination with, or in combination with for each, and then we can have our custom behavior. 2 second fade out. Okay. Not working again. You can see the difference now. Not working again. Okay. What do we do here? We're clicking this globy button and getting that very snappy, instant kind of behavior once again on the toggle. Okay. There is a bouncy animation on the query, but a filter is being done on the data, so this animation won't apply to the filtering. There was a bouncy animation on the query, but a filter. But a filter is being done on the data, so this animation won't apply to the filtering. Okay. Filtered parks equal just Canada, or what is this double question mark? Does he tell us on the next? No. Double question mark. This is ternary. So an or, so like this is like writing an if else, but what is the only thing that sucks about working with these slides is getting the fucking... Ooh, it's annoying. Oh well. If only... okay, it doesn't matter. We'll find out later. Okay, but okay, an animation.bouncy, and they're saying this doesn't apply because a filter is being done on the data. There's a way to fix this if you want the animation to happen on the filtering of data. Okay. So now let's take a look first at what it will look like. Ooh. Okay. Remove the animation parameter from the query property wrapper and wrap the filtering logic in the button using with animation, and you will see the animation working. Wait, so we removed it from the property wrapper here, bouncy, and so now this is just written per usual. And what do we do with animation? Bouncy, and then the trailing closure with our filtering logic. Is that all we added? Filtered parks, just Canada with animation dot bound. Yeah, okay. Okay, so we just wrap it, which is exactly what they said. Okay. Now, remove their animation parameter from the query and wrap the filtering logic in the button. Inside the button. Using with animation, you'll see the animation working. Okay. I mean, that makes sense. That makes sense. So not in the initial query, but on button press, it should come, or it should accompany the interaction with the button. So it makes sense to have the animation there, which is, that's what's so nice about SwiftUI in general. Sorry, I'm trying to get this knot out of my... It's declarative, you know, so it makes a lot of sense, and we would expect the same kind of logic elsewhere, where if we wanted an effect to apply to a certain action, then it should accompany the action directly where it occurs in the code, meaning like in a top-down fashion. Okay, so I mean, that makes good enough sense. All right, now... Oh my gosh. Ooh, I can feel the blood flow coming back in, brother. I did some shoulder presses yesterday. Let me just break this knot right here. Ooh. Oh, fuck. Okay, sorry. Pardon my French. All right, let's move on. With animation, you will see the animation working. Okay, yeah. All right, so we understand this. I understand this. Hopefully you understand this. That makes sense to me. So transaction animation. Let's see what it looks like first. Pow. Kind of looks the same, which is fine. How many times did he press this here? 1, 2, 3, 4, 5. However many times. Okay, animating changes with a transaction is another option. Animating changes. var model transaction animation, transaction trailing closure, transaction animation ease out duration 1.5 seconds. Weird. Okay, so first I would like to, just because, go and see, wait, I already forgot what it said. Go and see what that looks like. Model transaction animation in the code. Command enter. Yeah. So man, my short-term memory is dookie. Right? Model transaction animation. Animation. Yeah, brother. Okay. I just want to see what this is. it being transaction. No? Or sorry, not that. This. So it's a protocol. The context of the current state processing update. Pardon me. What happened to my... What's going on with my lighting, brother? So this is the downside of using natural light as your source of light. What have you done to me? Well, whatever. Guess we better hurry till I disappear. Okay, so overview. Use a transaction to pass an animation between views in a view hierarchy. Oh, use a transaction to pass an animation between views in a view hierarchy. To pass an animation between views. The root transaction for a state change comes from the binding that changed. The root transaction for a state change. The root transaction from a state for a state change. The root transaction for a state change comes from the binding that changed. From the binding that changed. Okay. That makes sense because it would be the thing being affected. So it makes sense to use the animation tied to the source value plus any global value set by calling with transaction or with animation, which is what we just did. Okay. So, well, wait a minute. Overview, open in dev docs. Yeah, let's take a bigger look here and see what's going on. Okay, it's a struct. Not that that's ultra critical, but just good to know. Managing animations, bar animation. All right. Not too deep. Okay, yeah. Oh, wait. There's one, it has one function we can call add animation completion criteria. Returns nothing, takes a closure, returns nothing. Okay. You can define a transaction's animation in a property and then pass it into your query. You can define a transaction's animation in a property. Oh, I see. Okay, that's what we did up here. Okay. So you put it into this bucket, model transaction animation of type transaction, and then its logic represented. See, look at that. Now it's going ham, brother. Come on now. What setting could oh, I know what I think. Just to clear that up real quick. Oh. That should be better. Hell yeah, brother. And then one more thing. Okay. Good enough. All right, now You can define a transaction's animation in a property and then pass it into your query. So we define it up here, throw it in here, transaction. So transaction is a parameter built into this macro, or one that it expects rather. Private var at query. Yeah, weird. So okay, I'm about to get used to that, but meaning passing in parameters to the macros. Remember back in the day when this is all we would write right there. Wow. Using good old type inference, but now this is cool. Okay, so query can have parameters, as can other macros, and transaction is another option in lieu of, what was the other one? Well, I suppose passing it in directly to the query macro, or wrapping it like so. Okay. Note most everything you can do with a transaction you can also do using the animation parameter. Most everything you can do with a transaction you can also do using the animation parameter, meaning this thing here. Which is good. I mean, that's far less verbose, right? So it's good to hear. How are transactions different from animations? Most of the time they work exactly the same. Transactions have other built-in functionality, such as being able to override animations, but that is beyond the scope of this book. Okay. Being able to override animations, but that is beyond the scope of this book. Okay. Summary. The main point is to test and be aware that the animation in the query might not always behave the way you would expect. The list view uses its own animations, but you can turn them on by specifying any kind of animation in the query. But you can turn them on by specifying any kind of, okay, irregardless of the value. So the fade out we can use, but the duration we can't control. Even though it lets us pass in whatever we want, it's going to ignore it. If the animation on the query isn't working, try using with animation around places where data is changing, like filtering. Makes sense, okay. Animations may not be accurately shown in the preview. Simulators and devices are more reliable. Okay, so the difference being this is the preview. The simulator is if I were to run the build, so Command B. Yeah, so this is what they're talking about. This is the preview. Command B or Command R would run the simulator. I'm not going to do it because I don't want to, but or using the app itself, installing it on your phone, like directly on your phone, your physical device. So that's the difference. All right, so going beyond query. In this section, you're going to learn about some alternative methods to using query, showing count, sorting, and filtering. We will learn about it right after this because I have to use the loo. So, BRB, brother. Or sister. 5 minutes. Ready to go. Your land. This land is my land. This land was made for you and me. What y'all know about that? You think they still got them singing that in school? Hell nah, brother. Nah, they might. I don't know. I remember that from elementary. Just it was stuck in my craw. Well, not stuck in my. It didn't. Never mind. That's the improper use of that phrase. It just stuck in my head. That's all. I have no issue sharing the land with all and proclaiming that the land belongs to all of us. Although I must admit it's a bit optimistic, but not a bad concept to convey to the children, you know. False as it may be. Politics aside, brother, sister. Let's get back to it. Now let's go beyond query, at query. In this section, you're going to learn about some alternative methods to using at query. Showing count, sorting, and filtering. All things we've covered thus far, if it wasn't obvious. Fetch descriptor. You saw that a model context object can do a query for data using a fetch function. We did, and it looked nice and very simple as opposed to the initial method that we learned. Let me start that over. You saw that a model context object can do a query for data using a fetch function, which is here. Which is... Wait, no, that's not a function. That's... Is it? No, it's a variable. But fetch descriptor is the function. And this is built in. I need to refresh on that one. I think that's right, but we'll see. Descriptor. A type that describes the criteria, sort order, and any additional configuration to use when performing a fetch. Oh, so this is not a fetch itself. Hence the name, so okay, that makes sense. So where is the function proper? What do they mean by static? Using a fetch function. What page is this? 149. Let me go back. 149. Let me go back to where that was. It wasn't that far back. I think it was literally just yesterday. Oh, so there it is. Okay, so it is just a method call on container. And it can take a parameter of the fetch descriptor type. Okay. So there is a dot fetch. So it's so confusing. I get what's happening, but each time I come back to it, it's or each time I take a little bit of a break from it, I just have to reacclimate my mind to remembering that by convention they're just going to do, like, we didn't have to call this fetch, or maybe we do, they haven't said that yet, but I just think that's so confusing. There's a fetch method, and then you want to call the fetch, so you might even have a fetch.fetch, or a fetch. Like yesterday, let me go back, there was, I'm pretty sure I literally saw a fetch. Which, yeah, right here. So there's fetch. I don't know. I don't know how I feel about that, but it just seems counterintuitive to me. But at least they've been consistent. They being the first book and this book, so there must be something to it. So I will make the adjustment. It never, I come from the world of SQL, so like you don't describe what you're grabbing in objects and abstractions. You literally just, if you know the schema, you call what you need. You get what you need. You don't have to do all this hoo-ha. But anyway, all right. So fetch. Now you saw that about a way I read that. The fetch descriptor is similar to the query macro. You can apply sorting and filtering to it. Okay. Meaning, okay, as a type, I see. So this is a type property. First 5 is a type property. Fetch descriptor is the type. And then the computed property value for it is fetch, or we establish what fetch is. And that's where we can say fetch is equal to an instance of fetch descriptor. And then on that descriptor, we can call the sort by and fetch limit modifiers, as they call them. They're just methods in SwiftUI. So modifiers, and the sort by is equal to, and this is what we saw in previous chapters, just normal logic for a sort. So sorting on a value. In this case, the name property of a park model. And this is the first time we've seen this, but fetch dot, and then another modifier, fetch limit. We can set that to an integer, so 5, and then we just return the object sorted and limited to 5. Okay, yeah. Okay. This sort by should look familiar. You saw this set before when talking about sorting. Yeah, exactly. We did. And part of what is really intriguing to me that I think I'm really curious to know how much programming you can fit into a PDF or an EPUB. Like this is, I found another knot right here. I'll have to get that one later. But yeah, I mean, I'm not sure. I think this is an EPUB, but there was also a PDF. I wonder what all you can do in there, because I assume this is going to just take me back, which, I mean, backlinks aren't anything, it's not ground shaking, but I'm curious what else can be done inside of these books. I just think this is so cool. So, part of my, not for this app that I want to build, but for my day job, I'm building out a curriculum we're launching this product line, this BI. It's basically like Data Analytics University, our version of it. And so I'm building out the curriculum, the interface, everything is what I've been tasked with. I just started last week, and we've been thinking web page, but I'm wondering how much of that I could bake into like an EPUB. I don't know. We'll see. But yeah, I wanna look into that. Maybe at the end of the stream, after we finish this chapter, I'm gonna do a little bit of research on that. I just think it's really neat though to have everything. Kind of like the reason I chose Go initially when I talked about using Go, to me there's just something very attractive about having like all your logic in one spot. Like it doesn't matter where, like as long as you got that one file, one EPUB or one PDF or one executable, everything you need, the entire product is just You understand what I'm saying, brother? Like, just consolidate it into one simple thing. I love the idea of that, but yeah. Curious what else this could do. So I wouldn't need it to do a whole lot beyond some simple animation, but yeah. Anyway, all right, so back to this. So then note, this property is not executing a fetch. It's not. Right, yeah, it's not. It's just defining what fetch is and then returns the object fetch, which is confusing to me, but now understood once you read through it. Not executing a fetch. It is just creating a fetch descriptor to be run later. It will get run on the next page. Okay. Yeah. Seriously, though, aren't these books great? I mean, these things are just great. Now, I don't make any money off Big Mountain Studio unless y'all want to sponsor me, brother, but no. Truly, just these are awesome because, like, a lot of these little notations here, which I assume they know this, that's why they put them there, but a lot of this stuff in the other book, which were more linear examples, just pages on a book, not slides and visuals and arrows. A lot of this stuff is what I would have to go dig into and, ask ChatGPT or Google it or whatever, but a lot of the little snippets of understanding that you need are just nicely, bam, right there. So, yeah, this will be a great reference down the road too, I would think. All right, now what else does it say? This is where you are setting the fetch limit to 5 items or less. Yeah, makes sense. You can't set this with the query macro. Okay. If you don't need all of the models available, this is a great way to increase the query performance. If you don't need all of the models available, this is a great way to increase the query performance. I don't know what that means exactly. If you don't need all of the models available. Oh, okay, never mind. I'm a dummy. Literally the models. So if there's a total of, 31 or whatever, but you don't need all of them, then you can just hit the limiter. Okay, my bad. All right, why is this property in the model? Why is this property in the model? Yeah, good question. It is simply for convenience. You can put it wherever you like. Oh. Okay. And we just chose to put it in an extension. And because it's a static var, that makes it available on the type itself. So you could call it anywhere, anytime, irregardless of the instance of park model. Okay, so now we will see. We're seeing the definition now, how it's defined. Now we will see how it actually gets run. Fetch descriptor parameter. Notice the park names were sorted first, and then the top 5 were returned. It's usually a video. I wonder why it's not now, but oh well. The query macro can accept a fetch descriptor to execute and retrieve data. Oh, I see what we did. Okay, yeah. So park model being the type, and then on that is the type property first 5. And so that's the parameter. So, okay. I guess they did say these are alternative methods to what we've already seen. And I like this better. I mean, that to me, that just makes sense. Because then you can just put your logic, separate it out into an extension, put it in your... Well, I mean, I assume we're doing this for like dev purposes. If say, as a developer, we wanted to write some helper functions for testing and all that. So we could just do it the way they just showed us and then throw it in the preview content. That way when we build, all of these methods don't go out, and then that's pretty cake, brother. So yeah, I like that. Or I mean, I like this. Yeah, I like this method better than what we've seen so far. Okay. So we just pass it in query into the query macro, as the first and only parameter. The fetch descriptor was created on the previous page is being passed in. Yeah, notice the park names are sorted first, and then yeah, okay. So we didn't see that, but I understand what's happening here, so that's good enough. Okay, good. Videos are back. All right, so dynamic sort and order. It's pretty gnarly, huh? Sort by region, sort by country, descending, ascending. Let's see that again. Okay. In this example, we need access to the model context to call its fetch function. Hence the environment macro, the value, model context. Now, I forget why we do the escape character, but I'm not going to worry about that for now. But we call escape, and then the modifier, model context. Well, I don't even know that that's a modifier. I just know that this is how we establish it. Don't remember why we write it that way, but, and then private variable, model context. Maybe this is something pertaining to conformance, not sure. In this example, we need access to the model context to call, okay. Here is another way to dynamically choose which field to sort by and in which order, ascending or descending. Sorting a property on the model is done by referencing a key path to one of the properties, which they told us this would be an example of a key path. The model and then the property. Ouch. All right, so so the sort by property and the picker tags are all using the key path type. Yeah. Oh, and maybe, okay, I think that's what the escape character was for. So that is part of the, or that's how we write a key path effectively. So it's not an escape character in that sense. Let's see. What is update parks? Well, we can guess, but okay, let me read this code real quick. So it's a struct, a query named by convention, dynamic sort and order. Of course, adheres to the view protocol, the environment macro, and then the key path to the context that we want to use. And then we throw that into a variable for use inside of our type here. And then we want all of these values to be tracked state. So these are all values that we'll be interacting with and will change. And then the body, an opaque type, some view, nav stack, a list of parks. And for each one, we want to display the park row view. Navigation title, so there's our title there. We want a toolbar, which is, I assume that's how we're getting here. And then the menu is sort by, which we see that. And then the picker, selection, sort by property. So the drop down, whenever they get in there, that's where that's where that's coming from. And we want to render the name region country in the picker, which we see at name region country. Okay. Picker style inline. So I guess that's the drop down menu there, or style there. Otherwise it'd be a separate, like an overlay window, something like that maybe, I don't know. Then a button, order ascending, ternary, so either descending or ascending. And then it just toggles it because it's a Boolean. So each time click that button, it toggles it. And then update parks. Okay. The update parks function is a central place used to refetch data whenever the sort or ordering are changed, or when the view first appears. It will update the parks property to update the list. So this dot on change of sort by property, trailing closure. So inside of it runs the function update parks, on appear, update parks. And then this is a private function, and its definition here, update parks. No arguments, or no parameters rather. And it takes descriptor, which is a fetch descriptor. Okay, so this is the method we just saw, kind of, with an implicit return. So we just get back the object parks, which is from the context, using our new descriptor, which would be using the updated sort. Okay, that makes sense. And then it returns a view. We know that because it's, well, it's SwiftUI, and they said that it always returns a view. So note, the update parks function will use the model's context fetch function to retrieve data every time the sort or order changes. This means a new fetch. I'm not tired, you're tired. This means a new fetch is done to the persistent store every time. Okay. So I suppose that's important to know if you're, hosting your database on AWS and paying for every fetch. You might want to be careful with that one, brother. Test to make sure this isn't causing any performance problems in your app. Usually it will not. Swift data is very performant, even with hundreds of thousands of models. Really? We'll see about that, brother. Warning, as mentioned earlier, the fetch function is ideal for read-only situations as it will not update the view automatically with any model context changes. Which yesterday we looked at how we can get around that anyway. There's a method, a pattern we can use to not basically get the best of both worlds. But yeah, if you're curious, you can look back at that. Otherwise, I'm sure we'll do more examples as we proceed. Accessing count from model context. Okay, so let's see what we got here. Parks 13. That's it? Okay. So we have this summary item, then we can drill down and see all the items that make up the 13. If you need a count of rows when the model context has a fetch count function. Oh, wait. If you need a count of rows, then the model context has a fetch count function. I see. Sweet, just built in there, eh? Just pass in a fetch descriptor to get a count instead of all the data. Oh, that's cool. Okay, I see. Yeah, all right. Why would I use this? If you do not need to display any data, then use this method of getting the count. This will use less resources than a query. Can I use a filter with fetch count? Yes. Since fetch count uses a fetch descriptor, you can add a predicate to get the count of parks in just one country, for example. Okay, that's good to know. Yeah, I mean, we'll probably use that in many places, especially the dashboards and whatnot. What is this task modifier? You just saw the first time I used task, and this might be a new modifier for you. Oh wait, I missed it. I showed it. Where? Oh, here we go. Okay. Task, parks count, fetch count. Oh, so I guess that's for like a non-visual action that should accompany, or that should be run within the generation of the view or returning of the view, is what that looks like. You just saw the first time I used tasks, and this might be a new modifier for you. If so, keep reading to learn more about what it is. If you're already familiar with tasks, feel free to skip this page. Task, closure, and then logic. Okay. Runs when the view loads, can run functions that are marked with the async keyword. you're going to, yeah, it's kind of like React's re-render or, you know, something of that sort. Whatever triggers, or is it use effect? I don't know. I'm just scarred from that anyway. So glad to be here not writing React. Did you hear about Microsoft Edge, how they dropped React? You know, the React Andes are just they're so bent out of shape. Can run functions that are marked with the async keyword. You're going to learn more about this in the concurrency chapter. If it calls a long-running async function and the view is unloaded before that function can finish, it can cancel the execution of it. If it calls a long-running async function and the view is unloaded before that function can finish, it can cancel the execution of it. Okay. On appear, run a code, runs when the view loads. Okay, so task, I guess, is more of a multi-tool, whereas on appear just has this one singular function. Okay. What is this here? At WWDC 2021, the task modifier was introduced. During a question and answer session, someone asked, are there any places where you think, yep, this is the place to use on appear rather than task? Apple engineer number 1. That's his real name. On appear is still fine to use. There's no need to update existing code that uses it. Going forward, I think task provides a more general solution, even for short synchronous work, since it sets you up to evolve towards asynchronous work if necessary in the future. Because it can handle async and on appear cannot. But if on appear was already working, there'd be no reason to replace it with task. Question, so would you always use task for new code, or are there still places where on appear is the right solution? I was maybe expecting to see on appear being gently deprecated or similar. Apple engineer 1. I'd always use tasks personally, but there's also a nice symmetry between on appear and on disappear that some folks still want to maintain. That makes sense. Question, is there really any difference? Apple engineer 1. While task cancels any async work at on disappear time, it doesn't trigger new work then. While task cancels any async work at on disappear time, it doesn't trigger new work then? I don't follow that particular answer. Apple engineer 2. We generally try to avoid deprecating things unless they are actively harmful, dangerous, tricky. As we mentioned, on appear is more limited than task, so I would recommend using it for new code. Huh? On appear is more limited than tasks, so I would recommend using it for new code. Oh, it's just worded in a weird way. He would recommend using task for new code, but on appear isn't harmful in any way. Okay. I think it made more sense before I read that square, but such is the nature of interpreted questions and answers. All right, filtering fetch count. When you call fetch count, you can use a fetch descriptor that has a predicate to get the count of rows that match your filter condition. When you call fetch count, you can use a fetch descriptor that has a predicate to get the count of rows that match your filter condition. Okay. So in the label, I say I want it to be named Parks. Oh, that's up here. Yeah, Parks. And the value. Oh, wait, that's a parameter. Value is a parameter, and I pass in Parks count. Format it as a number. Okay. And then inside of a task modifier, I say Parks count is equal to try. So if it fails, then just crash. Otherwise, I access the fetch count method on the model context, and then I give it this descriptor and then my predicate. See, what is the, oh wait, the fetch descriptor takes a predicate as an argument. Hash predicate. And then the trailing closure syntax. Park. So for each park in... Well, I want to filter for any model that has country equal to Canada, in effect. Okay. At the time of this writing, this fetch descriptor crashes the preview in Xcode, although it runs fine. Preview can't seem to parse predicates within fetch descriptors, so you can break it out into a variable. Next page. Okay. Filtering fetch count. Query underbar fetch count. Let me see if it still crashes. Query underbar fetch count. Fetch count. And oh, why wouldn't that's lame. Why wouldn't I be able to tab to the results? It's goofy. All right, query fetch count. And here, just want to see if it's still. I guess they fixed it. Cool. After preview works, let predicate equal park and yeah. I am sure at some point the Apple team will get this fixed, but just keep this option in mind if you need separate predicates. Okay, so here the predicate is inline, and then here I have a constant called predicate, and I throw that bad boy in there. And then instead I just pass it in predicate. Actually, I kind of like that better anyway. But this is nice if you're just trying to make shit happen too. I like both of them. They both make sense. Okay, summary. Here's a summary of some of the things you can do with a query. Topic. So here we can have the macro and then a parameter of sort. We pass in the key path as they define it. So escape character, the type, dot, the property name. And then of course var parks, and then it's of type array of park models. And so this can sort results by one property in a model and sorts in ascending, so A to Z order by default. Okay. We also saw this generic here, query park model. But for the sort, we can pass in this array of sort descriptors as we saw. So a different syntax if we want to be able to sort on multiple properties, in this case country and rating. And I guess the order, we can change the default, so it would be Z to A. Sort and order using multiple model properties, use an array of sort descriptor objects. And then what else did we see? Private var, sorted parks, array. And then this is a computed property. So what are we doing? Parks.sorted, park 1, park 2 in order ascending. What the fuck? Park name. What is this doing? Create dynamic sorting using a computed property. Oh, that's when we could, that was this here. The flipping, or here's an example of it, but the flipping back and forth between the, well, not that, but the descending and ascending. Yeah, okay. Sorting is done locally. A new query is not run. Right, we're just working with what's already in memory. Automatically publishes changes to your view when the order changes. Okay. Then we have another query. Using the filter parameter, we pass in a predicate. So we just saw this one, predicate inline, meaning we just throw the closure right there inside the argument slot. And so we're just asking for any parks with a country property that is equal to Canada. Filter using a predicate, specify a condition that results in a Boolean. Oh, okay, so that's the limitation. And that's a equality operator, so it's either equal or is not. So yeah, okay. And then what is this here? Query park model. So now we are filtering again. What's the difference? Filter predicate. There is no difference. Filter predicate, except for the park model. Predicate. Park in. So park being our iterator in. Oh, so that's just another way of filtering, because we want to treat, by wrapping it in parentheses, this this logic here, we're saying we want to filter for parks where the country is equal to the United States and the region is equal to Utah, not one or the other. Or country is equal to Italy, irregardless of the region. Okay. Filter using multiple conditions. Double ampersand specifies both sides have to be true. And double pipe specifies only one side has to be true, meaning logical or. Logical and logical or. And then we had query animation, ease out. Okay, so yeah, we just covered this, which we also learned that some might be overridden, like with the list view, regardless of what you throw in there. But there are workarounds for that. And then create a fetch descriptor that you can pass into query. Allows you to set a limit. Yeah. So we saw this 2 or 3 times, and I think I kind of like that the best. Meaning this method here. Separating out the predicate or the fetch descriptor or both. And then just passing it in. So now I went out to do all this stuff inline like here. We just have predicate, pass in the predicate. So, all right, model container. So we're gonna call it here, folks. That is, my brain has once again melted. But we will be back tomorrow. To thank you for coming out tonight, checking it out. Drop me a follow if you will. And well, I guess that's it. I was gonna say check out my other stream, but I already did my Halo stream. So yeah, guys, drop me a follow if you would, and follow me on X if you're not watching on X. I'd really like to pop there, just you know, because Elon's cool. No, I'm just kidding. No, because free speech and all that. And I feel like YouTube, Twitch, they both kind of had their kind of hairy business, you know. And I don't know, it would just be nice to get established on a platform that's not going to cancel me for saying some weak shit that's probably true. You know what I mean? Anyways, guys, take care of yourselves. Make sure you hydrate, eat a nice dinner, hug somebody.